Hello friends, welcome back to our channel. So today we'll discuss about one more important concept in machine learning, that is data representation. So we are saying in our previous sessions that machine have to be trained with a lot of data. So here the question is, in which format the data should be, right? So that is our session. So let us start the session. Data representation. So usually we can understand different types of data, right? So humans can understand the images, audio, video, text, uh, numerics, etc., etc. But machine can't understand all these formats. Okay, machine can be understand only a very few formats, that is a numerical form, right? So that comes the problem here. So the data can be any type, but machine can't understand everything, so we need to transform that. So here the conversion should be done, because so human understands, so which kind of formats, so human can understand numeric, text, that means alphabets, strings, images, so photographs, audio, etc., etc. So we can understand every format, but machine understands numbers, particularly the numerical formats, and mathematical values. Mathematical values, similarly, some vectors, matrices, etc. So you can know all these are of a numerical data type. Okay, all these are in a numerical form. So we need to this conversion, right? So how the text can be converted, how the images should be understood by the machines, and how the audio should be understood by the machines. So that is the data representation. So whatever the data available will be in all these formats. Okay, so let us see one by one. Let us see one by one the types of data representations. So first type, numeric data. Numeric data representation. So here already the data is in a numeric form. Directly we can make use of that data to train the machine learning in some cases. But if you go with some other examples, so there might be having a very large numbers. So in that we need to perform scaling. For example, let me explain you. For example, if you take a student performance, so what happens, so you'll be having the name of the student, or hours studied. Okay, hours studied, right? So so 10 hours studied may get some 80 percentage, some 20 hours study may get 95 percentage. So like this, these are all a numerical form. So directly we can train the ML model with this particular data. For example, you consider employees performance, employee salary prediction, simply we can say salary prediction. So you'll be having the dimensions like age and salary. For example, you can consider, so if it is 30 years of age, may get a salary of some 50,000, and 35 age with some 60,000. So you can observe, so there is a long variance between these two numerical data. So both are numerical, but there is a long difference. So in this case we need to use a scaling. So already in our previous session we have seen about the scaling. So one thing by we can use means min max normalization, and another one is a standardization. So we have seen two different techniques for scaling the different values to become in a single scale region, right? So these kind of things we need to apply for this kind of data. Okay, if this kind of data is there, directly we can apply to the machine learning, so we can train the machine learning. Okay, next, that's the first one, numeric data. We are having a two different examples we have seen. The second one, categorical data. Categorical data. So categorical data means we have seen it can't understand, the machine can't understand the text or categories. So we have seen a categories like some male or a female, and yes or no, and true or false. So like this we have seen a lot of categories. Okay, so we can categorize as a fruits, animals, like this, right? So in such cases we need to convert this into numerical form, numerical form by using encoding techniques. This also we have seen in our previous session. So I'll post the complete machine learning playlist in the description so that you can just go through the previous session, like the feature engineering. Okay, in that we have explained about this coding techniques. Coding techniques, right? So we have seen labeled coding, and one hot coding, one hot encoding, right? So these are the different techniques we have seen in order to convert this categorical data into the numerical form. So we need to apply this one, right? So if it is a categorical data representation, so these two already we have seen. And coming to the third data type, third type of data, it is a text data representation. Text data representation. So that means a strings. If our data is of a strings, right, so that should be converted into numerical. See, text data should be converted into numerical. So how this happens means, techniques. What are the different techniques? Okay, so the first technique is bag of words. Bag of words. So in this technique we need to find the vocabulary and we need to give the numbering. Okay, so generate vocabulary and give numbering. For example, let us take an example so that you can understand. So let it be machine learning is powerful. So you can apply the vocabulary. This is 1, this is 2, this is 3, and this is 4. And you can apply and give the numbering means frequency. Okay, you need to give the frequency. Okay, find the frequency. So how many times the machine appeared in this particular sentence? 1. Learning in this sentence? 1. Is 1. Powerful? 1. Okay, so this is how we need to find the vocabulary and find the frequency of each and every word. Okay, and in the next example, let us take I love machine learning. Okay, so here I, 1, love 1, machine. So here it appears once again, right? So again in this sentence it is 1, learning it is 1. So in this way it will be trained, the machine will be trained. Okay, so if the prediction if the prediction is machine learning is important. If I give this one, how it predict means machine learning 1, learning 1 is 1 and important is there is no, so it is 0, frequency is 0. So like this it will predict the words from this bag of words, which we can also represent with BOW, bag of words. So it will be having the complete words and their frequency, okay, their occurrences. You can simply say their occurrences. So this is a one way of converting the text into the numerical form, right? Second, TF, IDF. What is this TF and IDF? This means term frequency inverse document frequency. It stands for inverse document frequency. So what happens in this method means, so it will give more weightage to important words, right? And very less weightage to common words. So for example, here common words means you can see is, the, a, an. So all these comes under with the common words. So it will give very least preference to these common words. Okay. So example, if you consider the same text, machine learning is powerful. So if you observe this one, it will give a most preference to these three words and least preference to this word. Okay, so in this way it will be calculating the frequency and everything. So this is called as a TF-IDF format. Okay, TF-IDF technique. So term frequency and inverse document frequency. This is second way. And the third procedure, word embeddings. So here all the words will be represented with a vectors. Okay, so words are represented using mathematical vectors. So what happens? Similar words will have same vectors. So we'll be giving some vectors to the words and the similar words will be having the same vectors. So like this, the text data can be represented to the numerical way. Okay, and the next, after the text representation, I think it's 4. Image data representation. So how the image? So machines consider the images as matrix of pixels. So we know that image can be built with a group of pixels. Okay, image is a group of pixels. A lot of pixels will be there. So here the machine will be understanding the images as a matrix of pixels. So categories, first one is a grayscale image. If it is a grayscale image, okay, only 2 values. So pixel is represented with only two values. What are those values? 0 represents black color and 255 represents white color. So every pixel will be represented using only these two numbers, 0 for black and 255 for white. And coming to the second one, color images. Color images. So if it is a color images, the pixel will be represented with the three channels. Okay, so pixel is represented using three channels. What are those channels? So one is red channel, green channel, blue channel. So only three channels will be there. So if you want any other color, that will be a combination of all these three. So example, so if it is red, that will be represented as 255 0 0. So that is a red. And if it is a blue, let us take a green, 0 255 0. And if it is a blue, 0 0 255. So this is how the color images, the pixel in color images will be representing, right? So if you want some other color, that will be a combination of some red, some green and some blue. So the channel will be red, green and blue. So the combinations will be like this, right? So that is the color images. And sometimes the images will be represented in tensors also. So images, particularly in a deep learning, okay, in deep learning, images are stored in tensors. So example, it will be giving the height of the image, width of the image, channels, how many channels are there. Okay, for example, it is a 254 250 into 3, that means the height is 254 pixels, width is 250 pixels and channel is 3 channels, that is red, green and blue. So this particular tensors, the image will be represented in this format. So 254 pixels height, 250 pixels width and 3 color channels. So the image will be represented in these many ways. Okay, the next data representation is audio. Audio data representation. This can be converted in terms of some frequency signals or waveforms or spectrograms. So these are the different formats how the audio data can be represented. Okay, and the next one is a structured and unstructured. So this also already we have learned, structured and unstructured. So here structured means, so in a specific format, for example rows and columns, okay. So if the data is represented in rows and columns, that can be a structured format. So if it is an unstructured format, no specific format will be applied. Okay, no specific format. For example, images, audio, etc., all these comes under the unstructured format. Okay, and the last one is a feature selection. That is also most important. Feature selection, this already we have learned in our previous session. So not every field or not every feature is important, so we need to select only the important features, right? So that we call it as a dimensions. Dimensions are nothing but a features. So for example, some data may have thousands of features, that we call it as a thousands of dimensions. So that doesn't mean the predictions will be very good. So if you are having a more number of dimensions, automatically the computation cost will be more, and the training process will be very delay. And not every feature is important, we have seen that. And some data may have some 10 to 20 features. This is also a problem. So having a very less dimensions may miss some important informations. So we need to balance that. So we need to collect as much as of data, and from that data we need to select only the important information, and we need to ignore all the unwanted information, so that the algorithm, the machine learning model will be trained very fast, and based upon that we'll be getting a very quick decisions and very accurate decisions from the ML model. So that is the importance of dimensionality, dimensions or dimensionality, right? So these are all different types of data representation. So we have seen the numeric data representation, categorical data representation, text data, image data, audio data, and structured and unstructured, and finally the feature selection. So it's the most important. So once again I'm saying, so I'll post the complete playlist of machine learning in the description, and you just go through the previous videos so that you can understand what exactly the feature selection and scaling techniques, as well as the normalization techniques, okay, encoding techniques, everything I have explained in our previous sessions. So I'll stop here, and hope you understood this one. And if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.